download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about simple molecular substances. Now in the previous video we looked at covalent structures like this. So here we've got CH4. Okay, and what you'll notice now hopefully between these two structures is that they have full outer shells. Okay? The carbon in here has 8 electrons, the hydrogen has 2 and 2 and 2 and 2, therefore they have a full outer shell. Therefore they cannot be, or no more atoms can become chemically bonded to this structure here. No more atoms can come and join. Okay, it can't be bonded. However, if you add another methane molecule, which is CH4, it will be attracted to this molecule through a weak intermolecular force. Okay, so one methane molecule will be attracted to another methane molecule by a weak intermolecular force. Okay, now it's important to note, as I said, that this is a weak force and therefore it is easy to break. Okay, this is a weak intermolecular force. Now do not confuse that with the force of attraction between these hydrogen and these carbon. Okay, now we call these intramolecular forces. Intramolecular. And these are the forces that hold the carbon and the hydrogen together. These are really strong. Covalent bonds are really strong. So I'm not here saying that covalent bonds are weak forces. Covalent bonds are strong. So the hydrogen and the carbon are connected by a strong intramolecular force. But between the one methane, CH4, and the other methane, CH4, they are attracted through a weak intermolecular force. Okay, and it's important to get that. Now we call these structures, when they form these weak intermolecular forces, we call them simple molecular substances. Now there are many simple molecular substances that we could have talked about here. We could have talked about hydrogen, H2. Okay, so again, hydrogen and hydrogen, they bond here. That bond is very, very strong, but they then bond to another hydrogen, a H2, and that is a very weak intermolecular force there. So that is another example of a weak, of a simple molecular substance. We could have talked about chlorine, Cl2, nitrogen, water, carbon dioxide. These are all examples of simple molecular substances. Okay, so they have strong intramolecular forces between the atoms, but weak intermolecular forces between the actual structures. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. This therefore leads to having properties of simple molecular substances that are the same across all simple molecular substances. Now you'll remember us saying that the bonds between different molecules of our simple molecular substances, so here when we're talking about methane, the intermolecular forces here between them are weak. Okay, you remember us saying that. And what that means is that they do not require much energy to break. So although these bonds here, these covalent bonds that I'm sort of circling here, are very, very strong, these intermolecular forces here between the different molecules are weak. And because of that, it does not require much energy to break. And then we know from previous videos that that means that they have low melting and boiling points. Okay, so one property of our simple molecular substances are they have low melting and boiling points. The reason for that is that the intermolecular forces are weak and therefore they do not require much energy to break. And this is why most of the simple molecular substances are gases at room temperature. You will find the occasional liquid, for example water. Water is a simple molecular substance and it's a liquid. But most of the simple molecular substances are gases at room temperature as they have a low melting and boiling point. So one property is low melting and boiling point. The second property that we're going to look at that all simple molecular substances have is that they do not conduct electricity. And this is really whether they're molten, whether they're gas, whether they're dissolved, whatever, or whether they're solid, they do not conduct electricity. Now you need two things, remember from previous videos, for electricity to be conducted. You need a charge, and you need that charge to be able to move. Now because we're sharing electrons here, they're sharing electrons, they're not giving electrons, or they're not receiving electrons, they are not becoming ions. They are sharing electrons. So therefore, they have no overall charge. Okay, so simple molecular substances have no overall charge because they're sharing electrons, therefore they do not conduct electricity. So we fail on that first point there. Remember, you need a charge to be able to conduct electricity. They don't have a charge. So just to very quickly summarise, they have a really low melting and boiling points because of the weak intermolecular forces that require not much energy to break, and they do not conduct electricity because they have no overall charge. So now what I would like you to do is have a go at answering these three questions here, and then we'll go through the answers together. So pause the video now. Okay, so question 1, a bit of a throwback to a previous video. Draw a dot cross diagram for water. Okay, so it's going to look something like this because it's H2O. Okay, so what do we have in H2O? Well, we have two hydrogens. Now they each have one electron in their outer shell. So that's the two hydrogen, and then the oxygen. Oxygen has 6 electrons in the outer shell as it's in group 6. So what does that mean? Oxygen needs 2 and hydrogen only need 1. So oxygen is going to share 1 with each of the hydrogens, which is here and here, to get a full outer shell of 2. And each hydrogen is going to share 1 with oxygen so that it can gain its 3. Which means each hydrogen is sharing 1. Okay, so I'm drawing those in now. And each oxygen is also sharing 1 back in return to each of them. And I'm drawing that now. So that we've done that one, and we've done 2 of these, which means there are 4 electrons left to draw. 1, 2, 3, and 4. Okay, now we just double check. Hydrogen should have 2 electrons in the outer shell to be full. 1, 2, correct. This hydrogen should have 2 as well. 1, 2, that is correct. And oxygen to be full should have 8. 1, 2, 3, 4, 5, 6, 7, and 8. So that is correct. So that is the correct dot and cross diagram for water. Number 2, explain why it's difficult to separate the hydrogen atoms from the oxygen atoms. Well, that is because they are bonded by covalent bonds. Now, covalent bonds are very strong and therefore will require a lot of energy to break. Okay, so when we're talking about that, we're talking about these bonds here, the bonds between the hydrogen and the oxygen. They're covalent bonds, so they're very, very, very strong. Okay, however, when we're talking about that, if we draw another water molecule, the bonds between the 2 water molecules are weak. Okay, so that's why water has a low melting and boiling point. But these bonds here between the oxygen and the hydrogen are very, very strong. Now, number 3, water is a simple molecular substance. What would you expect its properties to be? Well, we'd expect water to have a low melting and boiling point. Why is that? Well, it's because of the weak intermolecular forces that require little energy to break. And we'd also expect it to not conduct electricity. And why is that? Well, it's because there's no overall charge. Therefore, they cannot conduct electricity. So 2 answers there, low melting and boiling point, and do not conduct electricity. So we've now looked at simple molecular substances. You can now test yourself with the quiz and move on to the exam questions. If there's anything you need help with, then please get into contact with one of our tutors and they'll be happy to help.